Welcome back, friends. In the previous session we discussed about glycolysis, and the session was enjoyable, but we forgot about the budget for glycolysis. Now we have this simple table which summarizes the budget about the glycolysis. Before we are going to discuss about the next procedures for respiration, let's discuss about the budget for glycolysis. Now, in this table of budget for glycolysis, we have total input and total output. In the total input side, we have 1 molecule of glucose, we have 2 ATP and 2 NAD. Then in the total output, we have 2 pyruvate molecules, we have 2 ATP and 2 reduced NAD, 2 NADH2, which are called as reduced NAD because of the addition of hydrogen. So overall profit is 2 ATP plus 2 NADH2. 2 ATP because the input is 2 ATP, then output is 4 ATP. So the net profit is 2 ATP and 2 NADH2. Every NAD can release 3 molecules of ATP upon electron transport chain, as how we shall discuss in the next sessions. So note from the above table, ADP, inorganic phosphate in the water, they ignored. ADP, inorganic phosphate in the water, they are not included in this description of glycolysis. Now after glycolysis, what happens is the reaction which is called the transition stage or the link reaction. Now after the molecule of pyruvate being formed, pyruvate molecule cannot enter the Krebs cycle as it is. So it should undergo modification to form acetyl. Acetyl is the molecule which enters Krebs cycle, and we have coenzyme. So we have acetyl coenzyme A. Coenzyme A is just not a substrate in such, because its function is to carry acetyl into Krebs cycle, or its function is to carry acetyl from outside of mitochondria into mitochondria. So hiyo ni kazi kubwa nani ya acetyl. Now in the link reaction, hii stage tunaweza kuita kama link reaction au transition stage. Kwenye hii reaction ya link reaction au transition stage, kinachokuwepo ni kwamba tuna convert pyruvate kwenda kwenye acetyl coenzyme A. And the rule of coenzyme A is to carry acetyl across the mitochondria membrane from outside of mitochondria into mitochondria. Kwa sababu najua Krebs cycle ina take place kwenye nini? Kwenye matrix of mitochondria. So tunachokisema ni kwamba tunakuwa tuna coenzyme A, then it combine with acetyl ambayo imekuwa formed from pyruvate, and that acetyl combine na coenzyme A, tunatengeneza acetyl coenzyme A. Kazi ya coenzyme A ni kucarry ile acetyl from outside into the mitochondria. Kwa tunachokisema ni nini sasa? Acetyl is the molecule containing 2 carbons. So conversion from pyruvate, which is 3 carbon, to acetyl, which contain 2 carbon, will involve the release of carbon dioxide. And this reaction requires the presence of oxygen. However, the rule or the actual place where oxygen is reacting is at the end of the electron transport chain. That is the last step of respiration. But the presence of oxygen enables this reaction, which is transition stage, to take place. Now this reaction does not take place in absence of oxygen. That's why we are saying that in absence of oxygen, only anaerobic respiration can occur. And in the anaerobic respiration, only glycolysis takes place. So in the anaerobic respiration, we don't have the stages like transition stage, Krebs cycle, and electron transport chain. In anaerobic respiration, we only have glycolysis reactions only. So now let's discuss about the transition stage. I have explained a little, and I hope this has given you a light of what we are going to discuss in the transition stage and also in the Krebs cycle. Now when we are discussing about the transition stage, we are saying that in the presence of oxygen, each pyruvate molecule enter the mitochondria, because you have formed the 2 pyruvate molecule. So the pyruvate molecule enter the mitochondrial matrix, of the mitochondria, where it is converted to an acetyl group, which can be written as CH3COO. These are carried by coenzyme A as acetyl coenzyme A. So acetyl coenzyme A, acetyl group have the 2 carbons. This acetyl group have the 2 carbons. So acetyl combine with your coenzyme A to form acetyl coenzyme A. Acetyl combine with coenzyme A to form acetyl coenzyme A. And the rule of coenzyme A, as I told you, is to carry acetyl from outside of mitochondria to inside. So acetyl group have 2 carbons, which is 2C. So the conversion of pyruvate to acetyl involves the loss of carbon, and this carbon is lost as carbon dioxide. So probably the need of oxygen in this reaction is because that oxygen will go to react with the carbon dioxide. I mean, will go to oxidize the pyruvate molecule and then to remove 1 carbon. So this is lost as carbon dioxide in decarboxylation reaction. A dehydrogenation also occur, so that reduced NAD is made from NAD. So unachoweza ukiona hapa ni kwamba hii reaction ina complex ya vitu ambavyo vinatokea all together at the same time, and you should understand all of these. You should understand all of these for your better performance of the exam. We have pyruvate here. This is the 3 carbon compound. Let I just decrease the size of this this ink here, so as we can understand each other. Now let me rub this first. Now we have pyruvate here, which is 3 carbon. This one is 3 carbon, and from there we are forming acetyl, which is 2 carbon. Acetyl is 2 carbon. So presence of oxygen enable the carboxylation of this pyruvate from 3 carbon to 2 carbon. Where does 1 carbon goes? 1 carbon is this one in the carbon dioxide molecule, which is formed here. Also in the same reaction we have decarboxylation, which is the removal of carbon dioxide, this one. And then we have dehydrogenation, we are removing hydrogen, so the reaction is called as a dehydrogenation, forming reduced NAD. Tunaposema reduced ni kwa sababu gani? Kwa sababu umegain hydrogen. Maana yake kulikuwa kuna hydrogen kwenye pyruvate, umegain hapa naita reduced NAD. So reaction involve decarboxylation and dehydrogenation. This is the same kama mtu angesema, let's say instead of putting these symbols, let's say kama mtu angesema tuweke only one arrow, mtu angeweka from oxygen then passing through to carbon dioxide. It is the same kama ambavyo tumeonyesha huko kwenye NAD. Lakini tunachoweza kuona hapa ni kwamba pia coenzyme A huwa anaingia, kwa sababu pyruvate anaenda kuform nani? Acetyl. So in this reaction also there is coenzyme A which enters from outside. Ni huyo hapa, so sikuiona hapo, lakini coenzyme A ndio huyo hapo. Coenzyme A ni huyo hapa, ameonyeshwa hapa anaingia. So coenzyme A also entered the reaction, and after entering the reaction coenzyme A forms acetyl coenzyme A, which is 2 carbon. Now acetyl is the carrier, carried by coenzyme to Krebs cycle, So we are going to continue with the Krebs cycle in this session. We are going also to continue with the Krebs cycle. So let's move to the next page, and let's start our discussion about the Krebs cycle, which is the second stage in the reactions of respiration. Now let's start discussing about the Krebs cycle. Sometimes it is called the tricarboxylic acid cycle. So we shall see how and why it is called as the tricarboxylic acid. The cycle is composed of different number of carboxylic acid, which tend to isomerize every time, so that to form different molecules. it tend to isomerize so that to form different molecules. Now let's continue with our discussion. We are saying that Krebs cycle, or sometimes it is called the TCA cycle, that is tricarboxylic acid cycle. Tricarboxylic acid cycle. In the Krebs cycle, we are taking acetyl after being produced from the ring reaction. The acetyl enter the Krebs cycle, and by the series of the enzyme controlled reaction in this Krebs cycle, what happens is that the end product is production of the 2 molecules of carbon dioxide and 2 molecules of ATP, also 2 molecules of NAD and 1 molecule of FAD per every cycle. So we shall see the mechanism on how this happens. So we are saying that although glycolysis releases a little of energy from the glucose molecule, the majority still remains or still locked up in the pyruvate. So glycolysis ina release only 2 ATP na zile NAD mbili, lakini energy kubwa inakuwa imebakia hapo kwenye pyruvate. Kwa reaction ya Krebs cycle ni very important. These pyruvate molecule enter the mitochondria and in the presence of oxygen are broken down to carbon dioxide and hydrogen atoms. So hii ni stage ambayo sio moja. Hiyo pyruvate mpaka ingie mitochondria lazima kuwe kuna nini kwanza? Kuwe kuna acetyl coenzyme A. Lazima kuwe kuna the ring reaction ambayo imetokea pale katikati. Now the process is called the Krebs cycle after it is discovered by Hans Krebs. So aliyegundua discoverer alikuwa ni Hans Krebs, ndio maana inaitwa Krebs cycle. There are a number of alternative names, notably the tricarboxylic acid cycle, TCA cycle, and the citric acid cycle. So normally if it is not called the Krebs cycle, it is called the TCA cycle, which is tricarboxylic acid cycle, or sometimes the citric acid cycle. While the carbon dioxide produced is removed at the waste product, the hydrogen atoms are oxidized to water in order to yield a substantial amount of energy. So in the Krebs cycle, we are producing 2 molecules of carbon dioxide, as I told you, per every cycle. But also we are producing hydrogen atoms which are carried by NAD, and some of them they are carried by FAD. All of them they enter the electron transport chain, and in the electron transport chain they release energy. So before pyruvate enter the Krebs cycle, it combines with a compound called coenzyme A to form acetyl coenzyme A. What is explained here is what happens in the ring reaction, as how we have described it in the beginning of this session. Now in the process, a molecule of carbon dioxide and a pair of hydrogen atoms are removed. The 2 carbon acetyl coenzyme A now enter the Krebs cycle by combining with 4 carbon oxaloacetate, which is oxaloacetic acid. So 2 carbon combining with 4 carbon oxaloacetate, we are forming 6 carbon compound, which is citrate or citric acid. Saying citrate or citric acid, it is the same name. Now sometimes the cycle is called the citric acid cycle. Citric acid cycle is because it is the first product which is formed by a combination of acetyl and oxaloacetate is citrate. Now coenzyme A is reformed and may be used to combine with a further pyruvate molecule to citrate. The citrate is degraded. Citrate is degraded to 5 carbon compound, which is called as alpha ketoglycerate. We shall see later. Here there are steps. It is not a single step to break citrate into the 5 carbon compound, which is alpha ketoglycerate. There are about 3 steps here, and then to 4 carbon compound, which is oxaloacetate, by the progressive loss of carbon dioxide molecule, thus completing the cycle. Kwa ukielezewa hivyo unaweza kuona kama cycle is very simple. However, it takes place in about 80 stages. Now for each turn of the cycle, a total of 4 pairs of hydrogen atoms are formed. 4 pairs of hydrogen atoms. 3 of them they are carried by NAD. 3 of them they are carried by NAD, and 1 of them it is carried by FAD. one of the hydrogen molecules, it is carried by FAD. So now let's continue our discussion in the next page. Let's continue with our discussion in this next page about the Krebs cycle. So we are saying that of these three pairs are combining with the hydrogen carrier nicotinamide adenine dinucleotide, which is the NADI. Nicotinamide adenine dinucleotide, which is the NADI, and yield 3 ATPs for each pair of hydrogen atoms in the electron transport chain. Kwa tunapozungumza kuhusu 3 ATP, hizi tunazungumza kwamba yield 3 ATP. Every molecule of NADI will yield 3 ATP in the electron transport chain, which is the third step of respiration of carbohydrate, is how we shall discuss it later. So the remaining pair combined with the different hydrogen carrier, which is flavin adenine dinucleotide. So by abbreviation it is called as FAD. Every FAD molecule yield only 2 ATP, and we shall see later why FAD yield only 2 ATP while NAD yield 3 ATP. In addition, each turn of the cycle produces sufficient energy to form a single molecule of ATP. Each turn of the cycle produces 1 ATP. So the net end product of our Krebs cycle will have 2 ATP. Why 2 ATP? It is because we had 2 pyruvate from glycolysis. So each pyruvate will release 1 acetyl, 2 ATP, and then here we have 3 pairs of NADI. So times 2, we have how many? 6 NADI H2. These are the end product of 6 NADI H2. These are the end product of a Krebs cycle. And from there we have also, here in FAD we have 1 molecule, so we'll have 2 FAD. You see, direct amount of FAD H2, direct amount of ATP ni 2, lakini from there tuna 6 NADI. Huyu 6 NADI aki-inter electron transport chain, 6 NADI, every NADI will release 3 ATP. So this is equivalent to 18 ATPs. 18 ATPs, as how we shall discuss in the electron transport chain. Also this easy 2 FAD ziki-inter, every FAD at least 2 ATP. So this is equivalent to a total of 4 ATPs. Lakini hizi hapa zinakuwa formed kwa nini? Kwenye electron transport chain, sio kwenye Krebs cycle. So from there also we'll have 2 molecules of 2 molecules of carbon dioxide per every cycle. So a total will have 4 molecules of carbon dioxide. These are the end product of the Krebs cycle. The end product of the Krebs cycle is how we shall discuss in detail later about the detailed mechanism of the Krebs cycle and its end product. So a single molecule for ATP, is produced per every turn. So Krebs cycle, which is 2 turn, will form 2 molecules of ATP direct. So it must be remembered that all these products are formed from a single pyruvate molecule. So the end product, the total yield form from a single glucose molecule, they are thus double those stated. Kwa kama hapa tumesema 3 NADI, malaki tutatengeneza NADI ngapi? 6, kwa sababu the final product is nini? The final product is double. Kwa sababu gani? 1 glucose molecule releases how many? 2 pyruvate. So things are like that way. So tunachokisema ni kwamba the details of this cycle were worked out by Sir Hans Krebs in 1930s. It is also called tricarboxylic acid cycle and the citric acid cycle because of the acids it contains. The acids exist as salts in the cell, so their names end with 8 because zina exist as salt. Kwa kama ambavyo unaweza ka name sulfate 8 because they exist as salt. Thus citric acid is referred to as citrate. So don't you wonder, kwa mfano tukisema alpha ketoglutarate au mwingine akisema alpha ketogluteric acid, it is because inavyo exist kama salt tunaiweka ketoglutarate, not as ketogluteric acid. Now the Krebs cycle takes place in the matrix of mitochondria. A summary shown below. Summary of a Krebs cycle, tunakuwa tuna acetyl group enter the cycle by combining 4 carbon compound which is oxaloacetate to form 6 carbon compound which is citrate. As the acetyl groups pass around the cycle, the 2 carbon atoms are lost in carbon dioxide into the decarboxylation reaction. The decarboxylation reaction, the reaction which involves the loss of carbon dioxide, and the hydrogen is added to hydrogen carriers in 4 dehydrogenation reactions, resulting in a total of 3 reduced NAD and 1 reduced FAD molecule. 1 molecule for ATP is also made directly from every turn of cycle. Remember, 2 turns of the cycle occur per glucose molecule, so oxaloacetate is regenerated at the end of the cycle, leading to accept another acetyl group. So what is explained here is just the summary. We will have the detailed mechanism of how Krebs cycle occur. This is just the summary so that you can understand the concept, and then we will have a detailed mechanism of how the Krebs cycle occur. So this is the overall reaction or the overall equation of the Krebs cycle. We have a C6H6 and then plus 6 water. We are getting 6 carbon dioxide plus 4 ATP plus. So hii ni overall equation ya glycolysis pamoja na Krebs cycle. Glycolysis pamoja na Krebs cycle, umeingiza glucose, umekuja ku end up with carbon dioxide, ATP pamoja na hydrogen. Hizi hydrogen 12, manake hydrogen kati ya hizi 12, hydrogen 4 zinakuwa zinatokea kwenye glycolysis. Kwa hiyo zikitoka 4 zinabaki ngapi? 8. Katika hizo 8, 6 zinachukuliwa na NAD kwenye Krebs cycle, 2 zinachukuliwa na FAD, jumla zinakuwa 12. Hiyo ni hesabu ya kawaida tu jamani, ni BAM, kwa hiyo usishangae. Now tunasema kwamba the hydrogen is on the hydrogen carriers which are NAD and FAD. All hydrogen from original glucose is now on a hydrogen carrier. All the carbon is lost in carbon dioxide. So unaona carbon 6 zimekuwa lost as 6 carbon dioxide. Carbon 6 zimekuwa lost as 6 carbon dioxide. Lakini unaona tukija kwenye kesi ya hydrogen kwamba hizi hydrogen unaziona hapa 12, zote hizi hydrogen 12 ndio hizi hapa 12. Kwa hiyo zimekuwa carried by hydrogen carrier. Lakini unaweza kuona kwamba huku tuko na oxygen ngapi? Pia tuko na oxygen 12, ndio hizi hapa oxygen 12, 6 mara 2 ni oxygen 12. So hizi water manake zimeweza kusaidia hapo oxygen. Kwa hiyo tunachokisema ni kwamba note from the equation 6 molecules of water have also been used. Water is needed as a source of oxygen in decarboxylation. As a source of oxygen in decarboxylation reaction. Some of oxygen in the carbon dioxide combined from this water. This is detailed which you can ignore. Kwa hiyo tunaweza tukaelezea kwa undani zaidi baadaye, lakini hayo ndio maelezo mafupi, short explanation of the Krebs cycle. And this is how the cycle can be shown. Hii summarization inaonekana kwenye BS namna hii, lakini summarization ya Krebs cycle kwenye BS ndio inaonekana hivi, lakini ni summarization kwa sababu nitakuonyesha diagram nyingine za Krebs cycle ambazo zimeelezewa zaidi na zinaweza zikakufanya uelewe zaidi kuhusu Krebs cycle. Kwa hiyo diagram ni summary, unaweza kuona tu hapo imeanza na pyruvate, imefuata hapo carbon dioxide inatoka, 2 hydrogens zinatoka. 2 hydrogen equivalent to 3 ATP kwa NAD hapa. Kwa hapa 2 hydrogen zinakuwa carried by NAD equivalent to 3 ATP in the electron transport chain. Hapa tunaenda kutengeneza acetyl coenzyme A. Acetyl coenzyme A ni 2 carbon, anaungana na 4 carbon kutengeneza 6 carbon citrate. Tuna remove carbon dioxide, tuna remove 2 hydrogen which is equivalent to 3 ATP. Hapa maana yake naye carry ni NAD. Then tunaenda kuform alpha ketoglutarate which is 5 carbon. Tuna remove carbon dioxide, tuna remove 2 hydrogen, tuna remove 1 ATP. Hii inakuwa carried by NAD, tunapata succinate which is 4 carbon. From succinate tunafanya reaction ambayo inaenda kutengeneza malate. Malate is also 4 carbon. Hapo ninatoa 2 hydrogen which are carried by FAD, so equivalent to 2 ATP, not 3 ATP. And from there, from malate we are releasing 2 hydrogen which are carried by NAD, tunatengeneza oxaloacetate. The detailed mechanism of the Krebs cycle, it takes place in 8 stages. The detailed mechanism of Krebs cycle takes place in 8 stages. And here we are starting discussing about the detailed mechanism of the Krebs cycle. So kwa sababu tumeshafanya about 1 hour, kwa unaweza ukapumua kidogo, ukapumua basic concept ya Krebs cycle uliyoelewa. Unaweza ukapumua, ukavuta hewa, ukanywa maji, ukastop video yako, halafu tukirudi tunaendelea na Krebs cycle in detail, kuelezea step by step. Now after the breath we can continue with our discussion about the Krebs cycle, is how we ended in the last few minutes, and I told you that you can stop your video, so I was just drinking water here. Yeah, let's continue. Now we are discussing about the details of the Krebs cycle, and as I told you that a Krebs cycle takes place in the 8 stages. So the detailed mechanism of the Krebs cycle will involve the 8 stages of Krebs cycle. Krebs cycle. So in the first step we are saying that once the acetyl coenzyme A has been formed, the acetate subunit combined with the oxaloacetate which is 4 carbon to form a molecule of 6 carbon with the release of coenzyme A. So we are forming citrate with the release of coenzyme A under the influence of the enzyme citrate synthesis. So it is very important for you to understand and to know the names of the enzyme, as how we discussed in glycolysis. The names of the enzyme, they are very important. Citrate synthase, that means the enzyme which synthesizes citrate. Now note the coenzyme A acted the transporter of acetic acid from one enzyme to another. Acted the transporter of acetic acid from one enzyme to another. As we know the concept of enzymes from the knowledge of biochemistry. So we are saying that the citric acid, which is 6 carbon, is converted into cis-acotinic acid, which is 6 carbon, by removal of molecule of water under the influence of aconitase. Sasa kuna baadhi ya vitu unaweza kama usivielewe, kwa sababu kinachofanyika hapo unaweza kusema sasa ni kama ujinga fulani, kwa sababu kwenye stage ya pili tuna convert huyu hapa citric acid kwenda kwenye cis-aconitase, wakati stage ya tatu tuna convert kutoka cis-aconitase is hydrolyzed into isocitric acid. Sasa unaweza kusema kwamba kwa nini hapa tusingepeleka moja kwa moja pale, kwa sababu hapa stage ya pili tuna remove water, enzyme inayohusika ni aconitase. Stage ya tatu tuna add water kwenye ile cis-aconitic acid which is 6 carbon, tuna add water, tunapata nani? Tunapata molecule ambayo anaitwa isocitrate au isocitric acid ambayo ni 6 carbon. Sasa huyu isocitrate tunayempata ambaye ni 6 carbon, pia yeye huyu isocitrate yeye anatokana na addition of water. So tunasema kwamba tuna remove water afu tuna add water nyingine, ni 2 different steps. Lakini the importance of this ni kwamba kama tusingefanya hivyo, manake hizo reaction isingeweza kwenda kwa ubora ambao umeweza kutokea hapo. Kwa hiyo mtakao kuja kwenye step ya pili tuna remove water, step ya tatu tuna add water. Tunapata nani? Isocitrate acid under the influence of the enzyme aconitase. Kwa enzyme mwenye kata hizi reaction ya pili na ya tatu ni yule aconitase. Lakini kwenye stage ya 4 tuna convert isocitric acid, tuna oxidize to oxalosuccinic acid which is 6 carbon, or we can call it the oxalosuccinate by hydrogen acceptor NAD, which is converted to NADH2 under the influence of citric acid dehydrogenase. So citric acid dehydrogenase or citrate dehydrogenase inakata the reaction of removing hydrogen from isocitrate kwenda kuform nini? Kwenda kuform oxalosuccinate. Kwa hiyo tunatoka kwenye isocitrate kwenda kwenye oxalosuccinic acid or oxalosuccinate. In stage number 5, oxalosuccinic acid is decarboxylated to form alpha ketoglutaric acid. Kwa hiyo tunafanya decarboxylation reaction, and in this stage we are getting carbon dioxide is one among the end product. Kwa hapa kwenye stage ya 4 tunapata nani? NAD wa kwanza. Step ya 5 tunapata nani? Tunapata carbon dioxide. A molecule of carbon dioxide is eliminated. Enzyme hapo under the influence of oxalosuccinic acid decarboxylase. Kwa hapo ukielewa tu molecule ile mwanzoni, unaona hapa citric acid dehydrogenase. Hapa enzyme inayofuata oxalosuccinic acid decarboxylase. Step ya 6 tunakuwa tunaendelea na nani? Na hiyo ketoglutarate. Na hiyo ketoglutarate yetu step ya 6. So in step 6, each molecule of alpha ketoglutaric acid loses a molecule of carbon dioxide and the hydrogen acceptor NAD is oxidized the acid by removal of 2 hydrogen atoms forming a reduced NAD molecule. Kwa hapa tuna lose molecule of carbon dioxide, lakini pia tuna lose nani? Hydrogen. So the product formed is hydrolyzed by addition of a molecule of water forming succinic acid which is 4 carbon. Kwa hii reaction ndio very complex. Tuna remove carbon dioxide, tuna remove 2 hydrogen, tunapata NAD, alafu at the same time tuna add water, tunakuja kupata end product kama nani? Succinic acid au succinate. Tunachokisema ni kwamba a molecule of GTP is formed which donates a phosphate group to ADP to produce 1 ATP molecule and 1 GDP. Asa hii ndo the most complex reaction kwenye steps za Krebs cycle ni hapa. Kwa hapa tunatengeneza GTP, guanosine triphosphate. This guanosine triphosphate ina transfer ATP yake kwenda kwa nani? Adenine diphosphate. Tunapata nani? Guanosine diphosphate. Na huyu adenine diphosphate tukimuongezea phosphate tunakuja kupata adenine transphosphate. Wewe hapo usipate shida kwa sababu guanosine ni organic base na adenosine ni organic base. I mean adenosine ni organic base na guanosine ni organic base. Kwa hizo zote zina uwezo za kuact kama groups ambazo zinaweza kuchukua huyo phosphate. From there step ya 7, succinic acid is oxidized into fumaric acid by removal of hydrogen atoms which are carried by hydrogen acceptor FAD, forming a reduced FAD molecule under the influence of succinic dehydrogenase. Kwa ukitoka pale ukimaliza ile step ya 6, hizi steps zinazofuata unatiririka tu succinic acid dehydrogenase, unatilika hapo, unajikuta at the end of the day umeshamaliza reactions zako za glycolysis. Reactions zako za Krebs cycle, kwa sababu unakuwa ni very easy hapo kuendelea huko mwishoni. So from there maana tumebakiwa na step moja ambayo tumebakiwa na step ya 2. Ya 8 ni fumaric acid is hydrolyzed by addition of molecule of water to form malic. Fumaric tunaenda kutengeneza nini? Malic under the influence of the enzyme fumarase. Afu ya 9 ni malic acid which is 4 carbon, is oxidized into oxaloacetic acid by removal of hydrogen atom, which is carried by NAD, forming a reduced NAD molecule. Reaction occurs under the influence of the enzyme malic acid dehydrogenase, na enzyme hapa juu anakuwa ni fumarase. Kwa hiyo the question which ask you to explain the details of the stages of Krebs cycle is not common. It's not common, lakini sometime can appear in your exam. Kwa lazima unajua hichi ninachokieleza, lazima uwe unakijua kwa kichwa, sio kwa kuangalia kwenye daftari, kwa kichwa. Kwa hiyo mimi naanza kuelezea kama unavyoweza kuona hapo kwa macho yako mwenyewe kwamba tuna acetyl coenzyme A, yule pale anaingia the reaction of Krebs cycle. Akiingia tu pale, water naye pale anaingia. So akiingia anaenda kuform nini? Citric acid, which is 6 carbon. Citric acid, which is 6 carbon. So from there tuna remove water, tunatengeneza nini? Aconitic, cis aconitic, ambayo ni 6 carbon. Hapa unaona kuna enzyme hizi tumename enzyme 1, enzyme 2, enzyme 3, enzyme 4. Tutakuja kuziname huko mbele. Enzyme 5, enzyme 6, enzyme 1, enzyme 2, enzyme 3, enzyme 4, enzyme 5, enzyme 6, enzyme 7, enzyme nadhani hapa hii hapa 5, hii hapa 6, hii hapa 6 imerudia tena. Enzyme wa reaction hii hapa na hii hapa anafanana, ni yule. Tutaenda kuona kwenye labeling baadaye, lakini tunachotakiwa kujua tu ni kwamba tuna enzymes huko. So hapa ameishia enzyme ngapi? Ameishia enzyme 8, wakati enzyme ziko reaction ziko 9. So that is the mistake. Enzyme 6, enzyme 7, enzyme 8, enzyme 9. So now that's not so much important, tutaenda kudiscuss kwa baadaye, lakini ninachotaka hapa ni tuelezee kidogo a detailed mechanism of Krebs cycle, kwamba hapa anapoingia huyo hapa acetyl coenzyme A tunakuja kupata nani? Tunakuja kupata cis aconitic acid. Tunakuja kupata cis aconitic acid. Cis aconitic acid. So yeah, so from there unakuja kuona ni cis sorry so tunakuja kupata molecule hiyo hapa ni cis aconitic acid, lakini tukiadd water kwenye cis aconitic acid, aconitase tena ana catalyze reaction. So tukiadd water in the tunapata isocitric acid. Tukiremove tukaform 1 NAD, tukaremove hydrogen tukaform 1 NAD, tunapata oxaloacetic acid. Tukaremove carbon dioxide tunapata nani? Alpha ketoglutarate. So unaweza ukachukulia Krebs cycle kama saa yako ya mshale. Kwa unaweza kusema hapa labda ni 12, unaweza kusema hapa 12, hapa 6, hapa labda 3, hapa labda ngapi? 9. Unaweza ukachukulia kama saa yako ya mshale. Hii itakurahisishia wewe kukumbuka vitu kwamba okay, pale kwenye 12 tuko na nini? Tuna citrate inaanza. Lakini kwenye kama around saa ngapi hapa? Hapa kama around, kwa sababu hapa kama hapa 6 hapa, manake kwenye around 5 hivi tuko tuna alpha ketoglutarate. Alafu tukitoka kwenye 5, kwenye around 7 tuko na nini? Succinic acid. Kwenye around 8 tuko na tuna fumaric acid. Kwenye around 10 tuko na nini? Around 10 tuko na malic, na around 11 tuko na oxaloacetic. Unaweza kuona manake 12 hapa, unaweza kusema hapa labda ni 1, hii hapa unaweza kusema ni 2, hii hapa unaweza kusema ni 3. Anyway, yani hiyo ni ili kumemorize kwamba okay, hii kama ni clock at around 1 hapo tuko na nini? Cis aconitase. At around 2 tuko na nini? Isocitric acid. At around 3 tuko na oxaloacetic acid. Yani hiyo ni techniques for you to memory. at around 5 kuna alpha ketoglutarate, kipita pale 60 at around 7 kuna succinic acid. But this is the most complex reaction kwenye reactions of Krebs cycle, kama ambavyo niliwaambia kule mwanzoni kwamba among the reactions of Krebs cycle, reactions ni nyingi, lakini some of them they are complex and some of them they are simple. Kwa ukiangalia hii reaction hapa, hii reaction ukishatoka hapa, ukifika hapa, hii hapa tuna remove carbon dioxide, then tuna remove hydrogen, then tuna add water. Tuki add water tunakuja kuform nini? 3-GDP phosphate hapa. Huyu phosphate huyu anahamishwa ADP anafanya reaction na yule. Huyu hapa akimpa phosphate ADP anaenda kuform ATP. Akisha form ATP, hapa tunatengeneza nini? GDP, kwa sababu GTP ni guanosine triphosphate. Guanosine triphosphate ikimpa phosphate adenine diphosphate kwenda kuform adenine triphosphate, kwa sababu hapa kwenye hii reaction maana yake hapa chini kuna ATP. Ukiangalia kwenye hii reaction hapa chini ambapo maandishi yaonekani, hapa chini kamera yangu ilikuwa inaonyesha nani? Inaonyesha hapa kuna ATP hapa. Kwa guanosine triphosphate amempa nani? Amempa phosphate nani? Adenine diphosphate kwenda kuform nani? Guanosine diphosphate. Hii ndio the most complex. Na hata unaona ATP ndio inakokuwa formed huko. So from there tuna succinic acid, pale tunapata fadi ile pale tunaongeza water, tunapata malic, tunapata nadi nyingine ile pale. Hii reaction haijaandikwa vizuri hapo. Hii manake hii hapa ya nadhani unaweza kuziangalia tu hizi nyingine. Kuna shida hapo. Manake unaweza kuona kwamba hii hapa unaona hizi zilivyo naandika nadi inaenda kuform nini? Nadi H2. Sasa hapa manake reaction imekosewa. Hii nadi H2 ilibidi iwe hapa, afu hii nadi ndio iwe huko. So hivyo ndivyo ambavyo reactions of Krebs cycle in detail zinaenda. Reactions of Krebs cycle in detail zinaenda. So kuna explanation za hizo enzymes. In the next page, lakini procedures ndio zile ambazo tumeelezea step by step. So in this page we are just simply explaining the enzymes. Unaona kwa enzyme A huyo hapo ni NAD, nicotinamide adenine. Huyo hapo reduced NAD, GDP guanosine diphosphate triphosphate adenosine, flavin reduced FADI. Enzyme 1 ni citrate synthetase, enzyme 2 ni aconitase, enzyme 3 ni aconitase, enzyme 4 ni citric acid dehydrogenase, enzyme 5 ni oxalosuccinic acid dehydrogenase. Enzyme sapa naona wamesema EM, that is the mixture of enzymes. EM ni mixture of enzymes. Pale ile stage ambayo tulisema hapa mwanzoni kwamba kuna stage, this one is catalyzed by EM. Hii stage hapa inakuwa catalyzed by EM because reaction ni nyingi, so it doesn't want to show you, but there is the reaction here. Sorry, there is the reaction hapa chini kuna reaction from alpha ketoglutarate tunapokuja kuform succinic acid. Kuna reaction hapa, you see. Hii reaction ndio ambayo tunasema inakuwa catalyzed by mixture of enzymes, kwa sababu reaction yenyewe ni complex. Lakini from there the reaction nyingine enzyme zake zinajulikana. Enzyme number 6 ni succinate dehydrogenase formaldehyde. So yeah, tuna essential features of Krebs cycle. Kwanza ni combination of acetyl with citrate. Naposema essential features maana ni vitu ambavyo lazima uvikumbuke kwenye Krebs cycle. Lakini pili ni oxidation of carbon atom to carbon dioxide in order to. Tatu ni production of energy directly as ATP, 2 molecule, and indirectly through production of electrons, which let form further 2 molecules of ATP for each sequence of the cycle. Hizo ni baadhi tu ya essential features, of Krebs cycle. Baadhi tu ya essential features of yeah. Let's see what is explained in this page. Yeah, I think this is the explanation of the electron transport chain. So yeah, let's naweza kuona hapo kuna products of Krebs cycle. For 2 cycle nakonda 2 molecules of water, 6 molecules of reduced NAD, 4 molecules of carbon dioxide, 2 ATP, 2 molecules of coenzyme A and 2 molecules of FAD. Hizo nadhani kama umeelewa Krebs cycle utajua zinatengenezwaje. In step 6, the product formed after oxidation of alpha ketoglutarate is succinyl coenzyme A. Succinyl coenzyme A is formed by addition of coenzyme A to the succinate ion. The step is not shown. Kwa hapo unaweza kaelewa tu kule kwenye stages kwamba kuna addition of coenzyme A. And from there we have importance of Krebs cycle. This is one among the commonest question ambayo inaulizwa kwenye respiration, the importance of a Krebs cycle kwenye respiration. Kwanza tunasema kwamba it brings about the degradation of macromolecules. The 3 carbon pyruvate inakuwa broken down into carbon dioxide. Lakini pili, it provides the reducing power ambayo inakuwa carried with hydrogen, ambayo inaenda kuproduce ATP at the end of Lakini tatu, it is an interconversion center. It is the valuable source of intermediate compound used in manufacture of other substance. Kwa hiyo hizi point ni kwambie utapita vitabu mbalimbali na vitabu vingine utazikuta nyingi zaidi ya hizi, lakini these are the basic importance. Kwa kuna nyingine ambazo utazikuta zitakufanya uwe confused tu. So now let's move to my book. I love this book, so let's move to my book and see what happens in the Krebs cycle step by step. So in the step 1, we have a acetyl coenzyme A, which can be shown like this way. We have a acetyl coenzyme A. So yeah, it is acetyl coenzyme A, and in this reaction we are releasing acetyl coenzyme A. So from there oxaloacetate tunakuja kupata citrate molecule. I just choose another color here. I think this will be best. So we are getting the citrate molecule, and then from there in the second step citrate is converted to its isomer, which is isocitrate, by removal of one molecule of water and the addition of another. Kwa unaona remove addition tunakuja kupata isocitrate, remove addition tunapata. Kwa kule kwenye explanation yetu sisi hizi step tumezitenga, ziko ngapi? 2, lakini sio mbaya kwa sababu hii ni Campbell biology. So ukichukua notes huku, ukachukua maelezo huku, kasema nimesoma Campbell, ni vizuri the reference book kuliko unavyokuwa unasoma kitu ambacho hakina reference moja kwa moja. So from there unapata isocitrate oxidize, unamfanyia oxidation and you remove carbon dioxide, you get alpha ketoglutarate, and then from there huu reaction unaweza kuona hapo nini ambacho kimefanyika. alpha ketoglutarate hapa umefanya oxidation tena umpata. Kwa hizi reaction ni kama kule ilikuwa moja, huku tumeweka ziwe mbili. So hapo unapata succinyl coenzyme A, succinyl coenzyme A, then unakuja unapata succinate, unakuja unapata fumarace, unakuja unapata malate. And this is summarized in the book of Campbell Biology. So as I told you that you can access this book from online, you can buy it, or there are many alternatives to get this book, but this is the Campbell Biology. So I hope by using this book you can enjoy many things about biology and our topic of respiration. Na hii ndio detailed mechanism of a Krebs cycle. This marks the end of our discussion about the Krebs cycle. In the next session we'll discuss about the electron transport chain. If you have any question, you can ask me in the comment, and I hope you have enjoyed the session. So if you need these notes, you can visit the Kipaji app in the Play Store, and from there you can get the notes by a very low cost, and it can help you learn for easy. Thank you everybody, and later wish you nice studies.